All right, let's talk about molarity. Molarity is synonymous with concentration, how concentrated something is. Give you an example. You have a cup of tea and you put some sugar in it. You take a sip. Ugh, that's not sweet. So you dump more sugar and you stir it up. Maybe you heat it up so that it can dissolve because, it never dissolves in iced tea, right? Well, that's molarity. That's concentration. And you always have two things. You have the solvent. See if I can write here. The solvent is whatever you're putting the stuff into. It's your dissolving medium. Usually it's water. In that example, it's tea. And then the solute is whatever you're putting in trying to dissolve. So the solvent could be tea and the solute could be sugar. If you have a glass of milk and you put in some Hershey's chocolate syrup, well, the milk would be your solvent, while the Hershey's chocolate syrup would be your solute. So it doesn't have to be a solid, just could be anything. So how do you find molarity? Molarity is literally defined as moles divided by liter. What does that mean? Got to have moles, got to have liters. So if they start with grams, go to moles. If they start you in milliliters, go to liters. Don't forget, 1,000 milliliters is 1 liter. Pretty easy conversion, you guys. So let's look at a couple problems. I've just got a couple of ones that I wrote down on a piece of paper we'll go over. So what if they ask you to find the molarity? What is the molarity when you have 0.312 moles in 0.1 liters? Well, if you look at this equation, it's just moles divided by liters. That's literally what you do. So 0.312 moles divided by 0.100 liters. And what do you get? 3.12. Two ways you could do your label. Moles per liter, totally acceptable. Or if you're lazy, 3.12, capital M. Capital M. It has to be capital. Can't be lowercase, something else. So make sure you do a capital M, okay? All right, what if, now this is fun. This is where molarity can be kind of interesting. Because you have this equation, you can find moles, you can find volume, you can find molarity. You can use it just like you would the speed equation. Speed equals distance over time. Same thing. So what if it asks you, how many moles are in 4.67 molar, by the way, that's how we say that M, if you have 200 milliliters, because let's make this a little bit more interesting, right? Well, you could do this two ways. One way is to use this as just an equation tool. So plug in what you know. Well, it's 4.6 molar. I don't know the moles, and it's in 0.200 liters. Remember, divide by 1,000 to get to liters. So how do you solve this? Well, cross multiply. X equals 0.934 moles. So that's one option. Totally acceptable. I like to use conversions. You know that. I'm kind of strange. So how do you do that? Well, first of all, you don't write 4.67 molar. If you're going to use this as a conversion tool, write it as 4.67 moles per 1 liter. It can also be written as this. Yep, how weird is that? Just make sure the number always goes with mole. You can use it either way. So what if we redid this problem doing a conversion? You guys know I always say write down what you know, dot line. So the dot line, the line is going to be one of those two pieces. So don't start with your molarity. Start with the other thing you were given. In this case, we were given volume. So if you have 0.200 liters, you're going to choose one of these to be your conversion. Now, do you want moles divided by liters or liters divided by moles? Well, you want the liters on the bottom so they cross off, right? Put the moles up here. 4.67, that's a decimal, 1 liter. And what do? Well, you just multiply. And you get that. So you can do it either way. I do like this because if you've got more in your problem, like maybe they ask you for grams. Well, you can go liters right to moles and then just keep going and go moles to grams. So I like the conversion piece. If you like using it as an equation, you can do that too. I really don't care. One more thing real fast is in this unit, we're going to talk about dilutions. How do you make solutions? I mean, we're talking about solutions, makes sense, right? We will use this equation again later on when we do acids and bases, and we'll bring it up again then. But for now, very, very simple. What if I need to create the following for a lab? And that is, I need to make a 3.5 molar solution. I only need 500 milliliters for the lab. And the only thing I have in my storeroom is 12 molar. And I'm going to use HCl because why not? All right. How do I do this? How do I make this? I want 500 milliliters, but I have to start with this. Well, this tool, the M1V1 tool, is just amazing. M is molar, V is volume. So, well, I have 3.5 molar and I want 500 milliliters of it. I have 12 molar HCl. How much do I need to use? Now, I know up above I just said you have to use liters. You can actually get away with not changing the milliliters in this case because this is molar and this is molar and it's going to cross off. And so your volume is just going to be in milliliters. Totally acceptable, totally fine. So how do you do this? Again, multiply those, divide everything by 12, and you get the volume to be approximately 146 milliliters. 146 milliliters of what? 146 milliliters of the 12 molar HCl. So how would you make this solution? You would get something called a volumetric flask, and it doesn't look like a flask. I'll show you in class. It's really pretty. It's round, but it's got this marking on the neck, and that marking is exactly 500 milliliters. Now, when you use acid and water, there's a rule. Always add acid to water and never the other way around. So you would actually fill this partway with water, and then you would add in the acid. And we always use distilled water. So you would add this into that and swirl it, let it mix because it doesn't need to dissolve. And then you're going to keep filling the flask to that point with distilled water. So it winds up becoming like 354 milliliters of water, but you don't need to actually measure it out. You could just use a volumetric flask and the line does it for you. It's kind of nifty. The other thing we're going to talk about is how do you actually make a solution? Again, you need to use one of these volumetric flasks, and I can't really draw, you guys know that, but they're really pretty. They just have this kind of round bottom on them. Well, what you want to do when you're doing, like let's say we want to make a salt solution, all right? You want to add some water, maybe a fourth of the way. Add some distilled water. D is distilled. Then measure out however much salt you need. And that is a little bit of stoichiometry. It's not that big of a deal, you guys. And then you put that in, the salt in. And you're going to mix this up, stir it up. You could shake it up. You could use a stir plate. However, once the salt is dissolved, then you go ahead and add distilled water up to that line. Now, why do I say that? So let's say we're making 500 milliliters salt solution. You don't actually use 500 milliliters of water because some of the space is taken up by this salt. Honestly, I don't really know how much you do use because we just use the line on the flask. But think about it. If you fill your bathtub up and you get in to the bathtub, the water rises, right? So this is how you properly make a solution. Add some water, put in your solid, get it to dissolve, then add enough water up to this point. And then you have made your solution. So let's say we were trying to make a 3 molar solution of salt. This would be 3 molars, 3 moles in a total of 500 milliliters, okay? If you were doing this. So just know, I probably didn't say that right. It's getting late. Just know the fact that if you're making a 500 milliliter solution, that doesn't mean you fill it up to the 500 mark, then put your stuff in because you're going to wind up overflowing your flask and you're not actually going to have the right molarity. And you'll see that as we work through the material. Sorry, this was kind of long-winded. Just wanted to throw a little bit at you about molarity. Go have fun.